Good day, I am Kim Ivan G. Velandres, and today I will discuss assignment problems. In mathematics, an assignment problem is a type of optimization problem that involves finding the best assignment of a set of resources to a set of tasks or jobs. It is also known as the maximum assignment problem or minimum cost flow problem. The goal of an assignment problem is to minimize or maximize a certain objective function, which represents the cost, profit, or utility of assigning each resource to each task. The constraints of the problem usually involve ensuring that each resource is assigned to exactly one task, and that each task is assigned to exactly one resource. Assignment problems can be represented using a matrix, where the rows correspond to the resources and the columns correspond to the tasks. The elements of the matrix represent the cost or benefit of assigning a particular resource to a particular task. We would be solving the assignment problems using the Hungarian method. The first thing to do is to subtract the smallest number in each row of the origin's cost table from every number in that row. Next is to subtract the smallest number in each column from every number in that column. After this, we can already check if the optimal assignment is already possible. So, we will draw the minimum number of vertical and horizontal straight lines necessary to cover all the zeros in the table. If the number of lines equals the number of rows and columns, an optimal assignment can be made, but if not, we must do another step to do so. Since the lines are less than the number of rows and columns, we must revise the current opportunity cost table through subtracting the smallest number not covered by any line from every other number that is uncovered, then add it to the number that is lying at the intersection of the horizontal and vertical lines. After this, we can now draw lines to cover the table if the number of rows and columns are equal, but unfortunately, it still does not satisfy the previous step, so we have to repeat it. Now, the number of rows or columns is equal to the lines. Then, we can make our final assignment. After much process, we have now found our optimal solution. We can now make the final allocation through picking a column or row with the least number of zeros and make the assignment. Eliminate that row and column and repeat these steps until all assignments have been made. Finally, we now have our final assignment, which is crane 1 is to job 1, crane 2 is to job 2, crane 3 is to job 4, and crane 4 is to job 3. We can now make the final allocation through finding a row or column with only one zero cell, then make an assignment for it. Eliminate that row and column and do the steps until all assignments have been made.